Hi everyone. This is Weimo from PuppyGraph, and thank you for the opportunity. And let me share some of our experience work with different cybersecurity company and what we look at their current data pipeline and data stack. Yeah, so we call a survey of cybersecurity data and how to simplify it. And I'm Weimo, the CEO and co-founder of PuppyGraph. And before that, I work in the data infra for many years in TigerGraph and also Google F1 team. TigerGraph is a graph database, and F1 is the unified SQL query engine inside Google. You can query all the data ITTs and in either real time or offline. So it's a kind of a Google version of StarRocks. Now it can directly jump into different data infra for different cybersecurity company, and I think you guys can guess uh, which the which company is using the current data current architect. And like for example, the first one we call architecture A. Since all the logs are streaming through Kafka into AWS S3 in Parquet file format, and then they need to support some dashboard. So the team is using Athena to fetch the data from Parquet file and put some of them into Redshift, because in their mindset, Redshift is the fastest and to support the dashboard. But Redshift is expensive and at the same time, and yeah, and yeah, it's a Fortune 500, 500 company, yes, and and what they're doing is that since they need to record all the logs and cannot delete and discard any of it, so they use S3 to store all of them in Parquet format, and then they define all the schema in Athena console. In this case, they can run some SQL query to create some tables and put it into Redshift. And in this case, they can use Redshift to support some of feature in dashboard, and all the unused data will stay in S3. And actually, this is one of the largest one in the industry, largest company. And here is another guy. It's a unicorn and cybersecurity company, and the data is also from Kafka, and it is well written into Google BigQuery, and at the same time they have Prometheus data, and because the data matrix is too big and they cannot load all of them into BigQuery, so actually they build a pipeline here to just extract what is useful for the future dashboard or some other features, and also put it into BigQuery and merge all of this in BigQuery and to support their dashboard. Uh, they even don't use data lake, and I think because they're still in high growth very fast and the funding is good enough, so they haven't considered about some other data lake hosting. They just put everything in BigQuery. And also, when I talk with their engineer, it seems that uh, different area have different engineer in different area have a very different skill set. And based on my experience, since they need to explain a lot of what they are doing, because the concept in cybersecurity and observability is also very complicated, but they spend very less time in the data infra. And of course, we share some of our experience and to help them maybe reduce the cost. But currently, the cost reduce is not their first priority, but I think they start to reconsider about the problem. And this is architect C. And what they are doing that since these guys know Iceberg since comparing with the previous tool, they know that Iceberg can manage their Parquet better than Athena, and they streaming all the data into Iceberg and they use Trino to run some offline job. At the same time, because their product is also dashboard, and not of course not a single dashboard, but is a very complicated product with a lot of dashboard. So they use Druid to support it, and then they build a data pipeline and loading the data from Iceberg, and I think they use a cron job to do it, and then the here Tableau and Looker is just one example. Of course, they have some home build dashboard as well, and then they use Druid to make it fast because in their mindset, the Druid is the fastest on the. It's not Netflix, but another company, but much smaller than Netflix. But it seems that this is a kind of common practice several years ago, and currently they are considering about migrating to the latest. Let's see the next one. Oh, this is another one, and they only have three, like Postgres, Snowflake, and Iceberg. And because the things is changed a lot at the beginning, they just load all the things from PostgreSQL to Snowflake, but then realize that is too expensive. And then currently the hybrid mode, since they migrate part of their tables into Iceberg, and but haven't finished the migration. So some of tables in Snowflake native tables, some of them in Iceberg, and they use Snowflake to query Iceberg as well. And also, but the most data are from PostgreSQL, and this is their current design. But based on my understanding of their plan, they're trying to delete the pipeline from and the CDC from PostgreSQL to Snowflake. And here we can have some public information with some famous company, and there is a drama here, and but all this information are public, so I can put the name of the company here. So this is a story. I write a blog about it since it's about a cloud security posture management product, and Lacework is the first one to do it, and their product called PuppyGraph. And here at the beginning, it's also load the data from Kafka, streaming data from Kafka to S3, and then put it into Snowflake, and the cron job running every 30 seconds to Druid to support the dashboard. But lately, they realized that Snowflake is good enough to do the dashboard. And here I make the diagram more clear. So it's a Kafka to S3, and to Snowflake, and to the dashboard. But the interesting part of that is their product is a graph. So it's a polygraph, but they don't use any graph database, but use Snowflake to write a SQL to express the graph query. And then another interesting story that Wiz, which is famous because I think one reason is it has been acquired by Google for 32 billion. And what they are doing is that they have a very similar product as Lacework. It's called a security graph, since Lacework called a polygraph. Both of them is the cloud security posture management thing. And but they use graph, just use graph database. So all the data here is supported by graph database. But I think this I only find this diagram for public from public information, but I'm guessing the system is something like this. So it's Kafka also to S3, and S3 can have backloading to Amazon Neptune, which is a graph database, to support the dashboard. And I think this sounds weird for the data engineer who familiar with the SQL data stack, since most people won't load S3 to PostgreSQL to support something. Usually, the data is from PostgreSQL to S3, but not the reverse direction. But in graph area, since we only have at that time we only have a graph database, so it's a common practice to load data from S3 to Neptune, and the cost so the cost is very high. And I hear news, we pay a very big money to Amazon Neptune, and uh, I at that time I guess 5 times, but still not in the same order of the real money value. And then here and then laterly, I think some other cybersecurity company also use graph database to do similar thing. For example, this company and it's also a public company which have a very large data set. And what they are doing is that they the data is also from Kafka and put all the things in Iceberg, and then use Trino to run the SQL query. And at the same time, because they also need a graph, so they load some data in Neo4j, some data in Amazon Neptune for different teams inside their company. But the similar problem is that the Iceberg cost is much lower than graph database, and the scalability is much better. It's something like you load the entire dataset from Iceberg to Postgres or MySQL is almost impossible. So what they are doing is that they have something like uh, they need to be very picky about data, like which part of the data can be put into the graph database. And another company, and it seems that they trying to solve the problem in another way, which is very similar to our philosophy. And since they realize that the cost is too high, and it's impossible to scale at their data size with a reasonable cost, and also they realize that when the data is big, is because most of the graph database is a single machine version, and which is a surprise to you guys, right? And and it's very hard to handle that big size of data. So what they are doing is that they still streaming to Parquet file in S3. At that time, they didn't know Iceberg, and we recommend Iceberg to them. And what they are doing is that they also use Trino to run the SQL query, and at the same time, they're trying to do a fork of JanusGraph to support a Parquet file. But then they realize that since JanusGraph is a single thread graph database engine, so it's very hard to handle the big data. And also, the engine itself is not only single thread, but also a single machine. So when the data is big, it's very hard to run complex query, especially when they're the hub node, and they need a very big memory to handle this query. But I think the philosophy is very close to us. We have to use object store to be the storage layer to save cost. So this is how we recommend our product and StarRocks, which is a combo to this customer. And the data is from Kafka to Iceberg, and thanks to the Iceberg community, and allow several products which is very good at this, like uh, Confluent Tableflow, Stream Native called Author Engine, and also Red Panda. They can directly write into Iceberg. Even the Red Hat log is directly in Iceberg. And then the cost is very low, and it can very close to real-time updates. And at the same time, when they want to support some real-time dashboard, they don't need to have a pipeline to load the data from Iceberg to Apache Druid anymore. They can just set up StarRocks on top of Iceberg tables, and then they can support the dashboard, which is in written in SQL script. And at the same time, they don't need because PuppyGraph we called as a graph engine, the StarRocks for graph. Yeah, so we follow the same philosophy on top of your existing table, like data, for example, Iceberg tables, and at the same time, we can support real-time graph query, and it's a distributed system, so there won't be a scalability issue, and we can make the complex query in sub-second. So, which is interesting is that most cybersecurity use case is not a database use case, is the either dashboard or visualize the attack path, this kind of stuff, or give a summary of how many how many CVE is related to how many instance, this kind of stuff. So the OLAP is very good for this kind of a step, but you can see that in cybersecurity industry, there's still no common practice yet. Everybody trying to figure out a solution by themselves, and there is a lot of workaround. And here we also support directly query the StarRocks data as a graph. In this case, it's even faster than we native run on top of Iceberg. Of course, a little bit expensive, but the performance is even better. So this is in this case, user can have all the data in Iceberg and don't need to care about whether is the tables, whether we need to have a carefully graph modeling. They can just stream all the data into Iceberg first, and then we can organize the data tables inside Iceberg, and then to support the real-time dashboard by StarRocks, and also the graph visualization and some attack path funding by PuppyGraph. And here is the architect. Of course, we can also support Postgres, and it's just interesting that Postgres Iceberg can have CDC, so you can have the latest. For example, if you need transactional updates, you can have 1 day data in PostgreSQL, and then you do the CDC to Iceberg, and then run graph query through PuppyGraph and the SQL query through StarRocks. And the more interesting combination is that you can use StarRocks to generate tables. And for example, if you have a transaction table on blockchain, or this, I think Eric is also here. This is a use case for Coinbase. StarRocks and PuppyGraph is a combo, and we have a lot of transactions on blockchain, and then we can use StarRocks to first run a group by. Since like A transfer 100 times money to B, maybe we can just have one edge to enough to do the graph analytic. And laterly, the table generated by StarRocks will write back to Iceberg or Delta Lake, and then use PuppyGraph to do the graph traverse, like where the money finally goes to, like A may be a frauder and transfer money to 100 fake accounts, and then transfer to 500 fake accounts. But finally, the money will go to some real account, since no one want to left the money, real money in fake accounts, right? So this is one of the example. And also our advantage that real-time graphnetic native support for two popular graph query language, which is openCypher and Gremlin, and no ETL, also scalable to petabytes. And here is some example we can easily show in graph query, like find network interface that not protected by any security group, along with their associate virtual machine instance. And this is the may pose to risk, security risk. And also find all the public IP address exposed to internet, along with the associated VM and the security group, subnet, VPC, internet gateway, and all the traverse paths. And also find roles have been granted access permission and associated virtual machine instance. And the last one is the security group that ingress route permitting traffic from IP address here to sensitive port, and retrieve these associate ingress rules, network interface, and VMs in traversal path. Yeah, this is several real-world query can express in graph. It's more like you define a graph pattern and return all your findings. So this is more like aggregation and analytical query. So, but in the last couple, maybe last decades, people are using graph database to do it. So in SQL world, there are a lot of changing data. There is a so-called modern data stack, and the technology involve a lot. But in graph world, it's still in the MySQL decades. So we're trying to let the graph world catch up with the modern data stack. And also we combine together with StarRocks to support some other industry like bank and financial technology, and also telemetrics analysis. And this is the content for our talk. Thank you, and please, if you have any questions.
Yeah, guys, thank you, Weimo, for that talk. Great session. Yeah, now we'll take any questions. There is the Q&A tab on the right-hand side, so feel free to drop a question in there with the few minutes that we have.
Oh, well, first question I saw is why do you have to read from StarRocks if you can read directly from Iceberg? Oh, this is interesting part. Since I think one of the common practice is that StarRocks on top of Iceberg, but we also have some joint customer that they even don't have Iceberg. They put all the data just in StarRocks, and because they are not that sensitive about cost, so all the data in StarRocks will have the best performance. And in this case, if we can directly run on top of StarRocks, we can match their performance requirement without considering about the cost. And also another question, looks like PuppyGraph prefers querying from Iceberg, but supports querying directly from Star. We plan on store data directly on. Yes, this is the case I just talk about. We have some customer, they don't need Iceberg to save cost, and they just have a StarRocks cluster. And we have joint customer like this, and we're trying to give them the best performance. And any customer who is using PuppyGraph on StarRocks for online model info at scale? Yes. And I'm not sure if did I miss any question. Can you tell a bit more about telemetry analysis with PuppyGraph? Oh, this is also a joint use case we work with StarRocks, since the data is in Delta Lake, and since one of customer export all the Datadog data into Delta Lake to do the analysis, and for PuppyGraph use case is that we help them to run some root cause analysis query. Like for example, if there is an outage, we can help them to find where is the what is the upstreaming and the downstreaming part, and then we can find out who is the root cause. Maybe the outage node is not the root reason; it's just be affected a lot and outage. But the root cause may be the upstreaming or downstreaming things. And which one is the better according to you based on its better cost pricing? Is having Iceberg on StarRocks or having StarRocks only? I think for the cost, if we consider about cost, StarRocks and Iceberg is a better choice, since Iceberg data is in object store, and S3 is almost free comparing with EC2. And in this case, you can also scale in and scale out StarRocks cluster. Like since the data is always on S3, and when you scale out and scale in, you don't need to reshard since data is already in Iceberg. And any customer who's using PuppyGraph on StarRocks for online modeling inference at a scale, it's going to replace. Yes, since the interesting part is that we have we saw some of you potential customer using Aerospike Graph, and it's an all-in memory solution, and it's super expensive. But at the same time, the philosophy of Aerospike Graph is that they just use the graph database engine, so it's not designed for complex query, graph query like a multi-hops. And what they are trying to do is that the engine itself is a single thread, not and also but it is leverage all the memory access and put all the data into memory. And at the same time, because Aerospike is a very fast key value store, so they did their optimization for the graph query is not on the query engine side. It's more like how to get the data from key value store faster. So I think in for the model inference at scale, it's more like OLAP query rather than OLTP query. So I believe that StarRocks and PuppyGraph is a better choice in this case. But of course, if you have OLTP workload, like you need to update transactionally update your graph data, I don't think StarRocks and PuppyGraph is a good combination for that. Can you speak a little about how you model graph as StarRocks tables? Oh, this is a pretty we're trying to make this user experience smooth. Currently, we have two ways. One is the auto-generated graph schema, but it's not, we cannot guarantee 100% correct. And if user understands their data very well, usually we will recommend to them manually set up the schema. We have a UI tool. You can just tell us this table is type of nodes, this table is type of edge. And if the table is type of edge, which column is from and which column is to. And after that, physically there are still tables in StarRocks, but logically you already have a graph. And then you can run graph query like a graph database. Graph query often need recursive exploration for friend of friends up to 3 hops or shortest path between A and B. How is handling Iceberg and StarRocks? Oh, this is what we are good at. Since we have an engine which is different than SQL query engine. Since the SQL query engine is optimized for SQL query, maybe it's kind of I think the word sounds awkward, but the SQL query engine and the optimizer is optimized for SQL query. But we have a graph query engine. We define the basic operator of graph query as node action and edge action, not like SQL define aggregation, joins, and also window function, this kind of stuff. But we only have main two basic operator. One is node action and another is edge action. And the input is a collection of nodes or a collection of edge. And after that, we define any graph query to be a combination of node action and edge action. And after that, for example, friend of friend is just a node action and then edge action to edge action, edge action. And then you can have the 3 hops. And also shortest path is kind of start from A and start from B and go along with edge action and until meet each other. And in this case, because for each basic operator, we can do parallel and also vectorized evaluation. So it's pretty efficient to have answer the graph query. And we are very good at multi-hop things. And we can finish a 10-hop neighbor query on 500 million edges within 2.2 seconds on a 4-machine cluster, and each machine have a 64 gigabyte memory. And also because Iceberg and the StarRocks combination is a column-based storage, and then the memory can be used much more efficient than the graph database. Since graph database, because they need to handle high QPS transactional updates, it have to be something similar to row-based. In this case, all the attributes in the same disk page, and when you're querying it, a lot of unnecessary attributes in this for this query will be loaded into memory, and then when the data is big, it's very easy to out of memory. And your graph engine is separate from StarRocks. That is, you don't convert graph query into SQL and run it on StarRocks. Since this is an interesting part, since I talk with a lot of friends, like since Databricks and is also our partner, we talk with the Databricks guys and also Trino guys, and also Neo4j guys. They all try to implement a graph on top of their engine, but because the engine is not designed for graph query, it's very hard to do it. And what we are doing that since I work at TigerGraph, so I work on Graph Engine before, and I also work at Google F1 team, which is the SQL query engine. So we kind of merge these two into one to take advantage of both of them, and that's why we are the only one to graph query engine, rather than since the most other graph tool are graph database, and we are kind of unique in this area. Yeah, I think that's all the questions, and thank you so much. Yeah. Uh, and if no other questions, and thank you so much for listening to the talk, and thank you so much for the very valuable questions. And of course, please, if you have any questions, please send me an email or reach out to our friends at StarRocks, since I know half of people in StarRocks, and we are very close friends. Yeah.